Okay, it shows us a picture of a circle, and it tells us what the radius is. Now we've got to write down an equation for the circle, so if we can work out where the centre is, it should be fairly easy. So we know the centre's got to be there, right? Now we know that the radius is 5, so that means that we know that horizontal line there, which I haven't drawn very well, that horizontal line there has got to have a length of 5. Okay, so what that means is, I think, that the radius of the circle, the x coordinate is going to have to be -5, and the y coordinate, because the centre's got to be on a level with this point here, 0, 9. So I think the centre's got to be the point -5, 9, and then we can write down straight away. Remember the general form of the equation of a circle, which I'll write down again. Looks like this, where the centre is the point AB and the radius is R. So right, now our centre we've just worked out is -5, 9. So if we plug these in, we're going to get x minus -5, or x plus 5 squared, plus y minus 9 squared equals r squared, but r is 5, so that's going to equal 25. And that's the answer to part A. Right, part B, a line through the point P at 8 minus 7 is a tangent to the circle. At the point T, find the length of PT. Okay, so what it's telling us is that we've got a tangent at this point T. Let's say it's there. Okay, and then we've got a line that comes in like that. This is the tangent, and it goes to the point, whoops. Right, and then it tells us that that goes to the point P, which is the point 8 minus 7. So this point here is supposed to be the point P, 8 minus 7. Right, and it's a tangent to the circle at the point T. So here's the point T, and we want to know, the length PT. Right, how can we do that? Well, to do that, what we need to know is that at the point T, the tangent and the radius going from the centre to that point, they're actually going to be at right angles to each other. They're going to be perpendicular. Okay, so we've got a right angle triangle which we can use Pythagoras on. If I just draw the other line, which is going to be this line here, okay, then it's a right angle triangle. The hypotenuse is going to be this line from the centre to the point 8 minus 7. So if I call that, let's call it A, the centre of the circle, I can then say that PT squared plus R squared has got to equal AP squared, just using Pythagoras. Right, so, and R squared we know, so PT squared, R we know is 5, so R squared is just 25. AP squared is the length from A to P, and remember we do that again using Pythagoras by subtracting the y coordinates and squaring what we get, and then doing the same with x and adding them. So we're going to have 9 minus 7 squared plus minus 5 minus 8. Minus 5 minus 8 squared. Right, 9 minus 7 of course is 16, so we get 16 squared plus minus 5 minus 8 is minus 13 squared, which is the same as 13 squared. So what we now have is pt squared equals 16 squared plus 13 squared minus 25 equals 400. So we've almost done it. So pt is going to be equal to the square root of 400, which is 20. Done. Okay, so to do this one, it's not too hard, but to be able to do it, you do need to realise that the radius from the centre of a circle to the edge of a circle will be perpendicular with the tangent at that point. Okay, so that gives us a nice right angle triangle that we can then use Pythagoras on.